The lookup transformation has three caching modes. The first is full cache mode. In this mode, the lookup data is completely loaded into the cache before the transformation begins processing the rows in the data flow, which itself is buffered as it's processed. This makes lookups extremely fast, often an order of magnitude faster than not using caching. This is the default option because if all the data fits in memory, it's definitely the fastest mode. Then at the other extreme, there's the no cache mode. With this mode, each row in the data flow is processed with a lookup against the data source. There's no caching and no buffering, so you potentially could have a huge number of queries against the lookup data set. This is virtually always going to be by far the slowest mode, so you should only use this mode when you've exhausted all attempts to use the other modes. On the other hand, this is the best option when the lookup data is constantly changing, so that you're always using the freshest data even as it changes while the lookup is executing. Because some of these transformations can execute for a long time depending on the data and what you're doing. And then there's a happy medium, the partial cache mode. This mode is the combination of the other two modes and provides a balance between memory use and performance. When the lookup transformation starts up, it doesn't preload the cache with any data, as the full cache mode does. So partial cache mode doesn't preload anything. It only adds the data as each row from the input data flow is processed. For each lookup, the component looks in the cache first to see if the key value is there before hitting the database. So this mode caches only the most recently used lookup data items, which limits memory use to a size that you specify. When the cache grows too big, the component replaces least used data with newer values. Ultimately, the decision about which mode to use needs to be based on performance versus memory use. Full cache mode may use a lot of memory for a large lookup data set, but offers the fastest performance. No cache mode requires very little memory, but is horribly slow because it needs to do a database lookup for every data flow row, although it uses the freshest data. And partial cache mode offers a happy medium between the two extremes. Ever since integration services in SQL Server 2008, the lookup transformation has also had a miss cache feature. The way this works is that if the lookup data set is in a database, miss cache optimizes performance by remembering failed lookup values, so that if another row in the data flow tries to look up a value that it already knows is missing, it won't try to hit the database again for that same value. This does take a portion of the cache because it has to remember those missed cache values. So you can specify how much cache memory the missed cache should use, up to 20% of the total cache memory. One caution here. You want to be careful when using caching for large reference tables with the lookup transformation. If the table contains too many records, again, this is the data that you're looking up against, not the data that's in the data flow. Because if the reference table contains too many records, it can cause severe memory pressure on the integration services server when the lookup transformation loads the reference data into the cache. And that harms performance more than several database round trips. Okay, so be careful of that. Once you start getting into large data sets, particularly on the lookup side, you need to think about caching carefully. Now, when you use the lookup transformation and its caching features, you'll want to set it up so that the larger data set comes into it from the data flow pipeline, and the smaller data set as the lookup or reference data that's cached. That's because when the lookup data set is loaded into the memory cache, the component is blocked until that completes. Then further complicating things is that you have to have the memory resources to hold it all, making it a challenge to use a multi-gigabyte data set as the lookup data. In some situations, you'll be forced to use a merge-join transformation instead of a lookup transformation when memory issues are insurmountable, even though you'll sometimes have the overhead of sorting the data in advance. And that really comes into play when performance becomes an issue. When there's so many lookups, you're not caching anything, it's doing so many complex lookups that performance just goes into the tank. Okay, so those are kind of some of the issues that you need to deal with. All right, so those are the features on the lookup transformation itself. There are also a couple of other components that you can use along with lookup and caching. And those are the Cache Connection Manager and the Cache Transformation. So the Cache Connection Manager supports some really advanced lookup transformation operations. It lets you populate the cache from any source. You can use relational queries, flat text files, an Excel spreadsheet, or even a web service. In addition, you can persist the lookup cache and use it across iterations of a loop operation. The lookup transformation automatically uses the Cache Connection Manager internally as its caching mechanism, but you can explicitly use it in order to exert more control over the process. The key feature that these components provide is the ability to load the lookup cache from any source. I really want to emphasize that. Not just an OLEDB data source, as is required by the lookup transformation alone. Then the components manage the lookup process instead of hitting the database, these cache components. Now you can populate the Cache Connection Manager in either of two ways. The first is that you can create a separate data flow task in the package in order to load the data from any source, such as a flat file or Excel spreadsheet, and then load it into a cache transformation. Then you configure the transformation to write the data to the Cache Connection Manager and use it as the source for the lookup dataset. Or you can write the data to a cache file that has the extension .caw. Saving the cache data to a DIS file is a great way to share persisted caches across users and packages. And then the other option is to configure the Cache Connection Manager to use an existing .caw cache file. So you obviously would have had to have created that cache file previously. Then, when you execute the package, the Connection Manager loads the cache directly from the DIS file. When you configure a Cache Connection Manager, you need to specify which columns are the key lookup data and which are the reference fields. It uses this information to optimize the cache for the fastest possible lookups. When you configure the lookup transformation that will use the cache data, you can opt to use a Cache Connection Manager instead of an OLEDB Connection Manager. You can use an existing Cache Connection Manager in the package or create a new one right from within the Lookup Transformation Editor dialog box. Then you can continue configuring the lookup transformation as though you were using a SQL query to generate the lookup dataset. From there on, it just uses the data automatically. The only effective difference is that you can only use the columns that you specified when creating the Cache Connection Manager, because you're defining the columns that are going to be included in the Cache Connection Manager instead of within the lookup. So using a Cache Connection Manager has several benefits. The first is that you can reuse the cache across users and packages and within loop iterations, saving the time of extracting the data over and over. And in particular, in the case of loop iterations, the cache would otherwise be reloaded for each loop iteration because you're defining a different data flow. Another benefit is that you can cache data from data sources other than OLEDB sources. This is sometimes the most compelling reason to use this technique, and it's a reason why I really want to emphasize it as a benefit. And finally, loading the cache from DIS file is almost always faster than executing a query against a database. And the data can be structured in the .caw file to make creating the cache more efficient than reading and processing the contents of a flat file. The downside here is that data in the cache can get old, and so you should regenerate it every so often, depending how often the source data itself changes. Now I'm going to explore a few of the caching features of the lookup transformations, and I'm going to use the package that I created in an earlier exercise. So this is reading product data, looking up subcategory data, looking up category, looking up model information, and then using that as the output data flow. So the one specifically I'm going to use is the model lookup. So I'll double click on that to configure it. This is a lookup transformation with the most lookup data in the database, 128 rows. All right, so this is how I originally defined it, using basically the defaults other than this ignore failure, which has really nothing to do with caching. Before I do anything, I want to come over here to the advanced page. As you can see, everything is disabled. It's all grayed out, and you have the message at the bottom that says this page is not used when full cache mode is selected. So this is the page that you go in order to configure caching for other caching modes besides full cache mode. All right, now I'm going to come back over to the general page here, and I'm going to select no cache for the cache mode. So notice here, that caused this to be disabled. Because I'm now not using a cache at all, I can't use a cache connection manager, which kind of makes sense. If I'm going to cache data using a cache connection manager, I kind of need to be using a cache. Otherwise, it's just all kind of a waste of time. All right, now I'll go back to the advanced page. As you can see, this custom query has now been enabled. This lets you modify the SQL statement that's used to perform the lookup. And so it's a little bit kind of convoluted SQL, but the main thing here is that it's using this product model ID as the lookup key. And then during execution, it supplies the value for that question mark. Now, remember that with the default full cache option, the full lookup data set is loaded into memory before the lookup transformation began processing rows in the data flow. So all of that data from the lookup table, using the fields that I specify, is already in the cache in memory. Okay? But in this case, every time, if I'm not using a cache, every time it does a lookup, it's going to have to go out and hit the database table. So that's why the no cache option, one of the reasons why it is so much slower. It's doing a lot of database lookups. All right, so anyway, this is the query that is used for that lookup. And you can change it if you want to. The other thing is if you look at the bottom here, it's a little bit out of view. I guess there's no way to scroll down. I can make this a little bit bigger. Okay, you can see the approximate cached row size in bytes is 142 bytes. Okay, so that gives you an idea of how much data. You definitely want to keep that as small as possible to use up the least amount of memory. Okay, once again, I'm going to go back to General here, and I'll use that middle of the road option, Partial Cache, and go back to Advanced one more time. And now this Advanced page is completely enabled. At the top here, you can specify the size of memory for both 32-bit and 42-bit caches. And as you can see, 25 megabytes is the default for both. See this option here, Enable Cache for rows with no matching entries? This is the Miss Cache option. So I can enable that and then specify however much percent of this cache memory that I want to be used for those miss cache. Okay, so I'm going to turn that back off. And now I'm going to accept those changes. Remember, I'm in the partial cache mode. And I'll run the package one more time. Now, I can't really tell how fast or slow it executed. Probably no effective difference with just 504 rows. But get the same row of data. I'm going to allow this to progress to completion and close the data viewer. But what's interesting here is the progress window. Let me get that out of the way. Because this actually changes when you're using caching. Okay, first thing is there's a few warning messages. Just want to let you know about those. Could not open the global shared memory to communicate with performance DLL. Data flow performance counters are not available. Didn't define any, so they're not available. So that's just a warning message. But then the interesting thing here is you have all these warnings about the output column list price on output union all output 1 and component union all was not subsequently used in the data flow task. Removing this component can increase data flow task performance. Okay, so those are just telling you that the union all is not a true endpoint for a package. We just use this as a convenient place, slapped on a data viewer so we could see the data. We didn't have to configure any kind of output. We didn't have to go out and look at a flat file. We just used union all as a convenient way. So that's why those error messages are there. But then it gets a little bit more interesting regarding caching a little bit lower. So you can see it's preparing for execute, gives status messages. And then it does things like category lookup has cached 4 rows. Remember there were 4 categories, so it makes sense that there's 4 rows in the category. And then it has a cached a total of 4 rows. Number of unique rows is 4, and it processed 4 rows. So you can get some information about the sizes of the different caches. So as you can see, subcategory had 37. And you can also get information about how long it took to load the different caches. So the processing time took here 0.001 seconds, 0.001 seconds, 0.001 seconds. Makes sense, not very many rows. This is a tiny amount of rows for this kind of operation. But if you do get big bottlenecks, you can come here and find out what the heck is going on.